In a year 2024, where men have landed on the moon and have gone out of their mind so crazy that we're launching cars into space. With all that technology, it is hard to believe that the premium GPUs still continue to break. And this MSI is no exception. Hello Internet! Today we have this 3080 in for repair. Customer stated something along the lines of fix it fast. So here we are, trying to fix it fast. Customer wanted to get this thing fixed so fast, he ended up marking the problem areas with the stickers indicating missing components, broken traces, and rust. I'll do a basic sanity check just to make sure that nothing is shorting, and with that done, I could try to see if it produces a picture, but according to this PDF file, one of the broken connections is the clock, and will most likely prevent it from communicating with the motherboard, so I decided to address all the visible problems before powering on, so let's do that first. Okay, connections have been restored and the components replaced. I will now power it on, and looks like we're missing 1.8 volt rail. Circuit that generates this voltage is on the back of the board, so let's go there and investigate. Once chip is identified, referenced in the datasheet, we can test the pins in order to diagnose the problem. In this case, I want to see the enable pin, which does have 3 volt. We have 12 volt coming in, and we have boot, but no power good. That looks like a dead buck converter, so let's replace it with the one from the donor board and see if that helps. Okay, part is replaced, and as you can see, we have 2.3 volt instead of 1.8, which is a big no-no. One possible reason for that would be something wrong with the feedback circuit. So what I did was I lifted all of these components, resistors and capacitors straight up like that, and measured them one by one to confirm that they are actually good. And with that out of the way, that leaves me with only one option. The buck converter itself is at fault, so I'll go ahead and replace it with another one. With that done, we now have 1.8 volt. All other voltages also present, so it was time to boot the card and see if we get a picture. No picture? No problem. I'll just try a different display port, which does seem to work, so it looks like we have a problem with an HDMI port. On the back side of the board, I checked every capacitor and every coil, and everything looked good. The only thing I suspected the problem would be is this trace that's supposed to go to the other side of the board through this rusted via. Testing the connection between the via itself and the trace seems to be making a good connection. This connection is supposed to be making contact with the HDMI port, pin number 10, so let's see if that's true. As I was trying to test the continuity, my probes decided to switch to wireless mode, so I was unable to use them anymore. But lucky me, I was able to switch to the good old probes, and this time I was able to verify that the connection between the trace and via does not exist, and that the via is rusted through and the connection is simply not making its way all the way through to the HDMI port. So the solution is to reroute the wire somehow, and what better way to go through the board if not use the existing hole here on the side. I will simply run the wire through the hole, solder one end of it to one side and another one to another side, just like that. And now that we have connection going all the way into the HDMI port, let's boot the card again and see if we get a picture. Great! All that's left to do now is to make everything look pretty. Maybe make that wire a little bit shorter to minimize any negative side effects. And that should be it. Card now works great, passes all the tests, and it's time for it to go back home. As for you, hopefully this repair has earned me your subscription, comment, or a like. Otherwise, have a blessed day. Goodbye.